And we are back. EHS 370, Environmental Epidemiology, also known as Environmental Disease Detective, starting in fall 2020. And what we are doing in this video is we're providing an example of how we can use some of the new serologic tests being developed for the global pandemic for us in the United States or wherever to potentially investigate how far and wide this particular disease has traveled. And this information is valuable from a planning perspective as well as for us to understand and evaluate our previous and current actions such as social distancing. Now I'm going to pull up the slide here on the cover and you can see this image that is provided from BioMedomics. It's a company that's based out of North Carolina, to my knowledge. I think they have got about 14 employees or so. It's in Triangle Park. Strong research center there as a community. And you can see this image from them where it shows you what the results are of their particular test. And we're going to discuss this test along with a few other ones here in the next few minutes that we're together. Now, as you remember from earlier, we talked about SARS-CoV-2 testing, which is required for determining if somebody is a case or not. And we mentioned in that video that some people think that this litmus test type approach is how easy it is to get one of these tests done, and they can't figure out why there's such a headache associated with getting these types of tests done. And although there have been setbacks, these tests, when you're trying to measure direct virus, are not exactly easy to do. So we know that it is not that simple. We know that it requires RT-qPCR, which we'll talk about here in a few minutes. Now, we need cross-sectional surveillance studies to be able to be done at some point here in the United States. We also have a lot of other needs for these, what we call serologic tests, these tests that measure immune responses. And you'll understand more fully why that's the case here later, because there are clinical benefits for treating patients. There are benefits for evaluating the effectiveness of vaccines. There are all kinds of other reasons why these serologic tests are valuable. But one of them is because we are interested in actually being able to see what is the amount of antibody in our existing population with respect to individuals across the population. So we may be interested in doing a cross-sectional serological study where we're looking for the prevalence of these antibodies in the American people. This type of information is very important for us to be able to understand how many people have already been infected, how many people are healthy and can potentially go back to work, how many people who are on the front lines of treating ill patients or who might be in the hospitals working with potentially ill patients. How can we put the people who are immune right there with the people who are most likely to shed the virus? So we can use that information for a lot of good reasons. But one of the reasons why we want the prevalence information is because we want to know when this disease started in our community. We want to know how effective our interventions like social distancing actually are for preventing disease spread. We want to know how far along in our epidemic curve are we, so that we might know or prepare or plan for our hospital resources and bed space. So there's a lot of reason why we would want serologic testing to be able to be done, not just at a national level, but community by community. But part of a nationwide survey would be wonderful. And it would be not just like looking at cases and controls in a hospital, there's value there, but even more of a random-based, let's just see how prevalent this virus is right here in the United States. Similarly, other parts of the world, particularly in China, we'd be curious as what's the seroprevalence of it there? And if you couple it with questions like, did you ever have a fever? Did you ever have these other things? We might also learn about how many people actually ended up with the actual disease, the actual full-blown disease with fever and all. How many people had pneumonia? How many people didn't even have symptoms? If you're able to randomly sample, like we know from cross-sectional studies, we can learn a lot from the prevalence and get those prevalence odds ratios that can be helpful. So what goes in to these serologic tests? So these images are from this company. So there's their little kit. It's probably not going to be cheap because whenever you're working with antibodies, antibodies are expensive to produce. And we'll talk maybe more about that here later. And a person can be either negative, they can have an IgM positive result, and that's when there's a red line on the M, like right there. They can have an IgG positive result, or they can be positive for both the IgG and IgM antibody. And by knowing that information, we can learn a lot about the history that they've had with this virus. There are other companies that are out there, and there's a whole lot of them that are competing for this type of information. Here is an example of a demonstration from this SureScreen Diagnostics, very similar in terms of appearance. Just today, as I was pulling up the images from the first group that you were looking at, or the first lab you were looking at, I saw similar images show up on my social media page, and I thought, man, you know, we've got all the same information almost. And I was just curious. Well, then I wound up reading a little bit more. So this is a friend of mine from OSU, a fraternity brother of mine, who's went on to do great and wonderful things at Mass Gen nowadays. He was at Case Western, and I opened up their stuff, and then I read their Twitter feed, and my gosh, there's a lot of cool stuff going on in this particular area. And they were evaluating the effectiveness of these tests. I just knew that that test was on the market in China, and I knew that the FDA was looking at approving it for use, and I was curious about how good it might be because I was skeptical that the other studies that had been done on it that I knew about were all done overseas, and I was curious as to how it might be done here in the United States. So I was pleasantly surprised actually when I saw Dr. Miller and his team's presentation on Twitter today. So what does he have in his slides? A few things that I think are important. One thing that's important is it's important to know that when a person actually starts developing the IgM antibody, it goes up, 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 all the way to about day 7 to day 14 or so, and you'll have IgM antibody at a fairly high level at this point. And then it'll eventually go down, which is true for almost all things. IgM antibodies are the first ones that show up. They're very prevalent in the blood, and particularly in the lymphatic fluids, the lymph fluids. IgG is a more common antibody, and it's more long-lived, and it's pretty much in all fluids of the body. IgG lasts longer. So that helps us a little bit here. We'll get into that more in a minute. But these types of tests are great because these serologic tests can tell us if they've ever had a SARS-CoV-2 infection or not. They may have never had symptoms, but the antibody response will tell us if they've ever been exposed. Also, if they've ever been vaccinated or not, or if they've been exposed to something else that potentially has given them a potential immunity. So we can identify people who have immunity. We might be able to use these tests to determine who can go back to work. We can identify the people who are asymptomatic. Maybe they've got increasing IgM levels, but they've never had a fever. They've never felt like they're sick. They could potentially be a major risk group with respect to sharing the virus to people who would be potentially sickened and maybe even die from it. So we could screen people who might be infected. We could also understand how people are responding to the disease. And then lastly, we could identify, these are medical treatments, they could identify somebody who's got a great immune response and they're producing high amounts of antibody that could then be used as therapeutic, plasma that could be then given to people who are really sick and needing help. So those are kind of the benefits of using this approach. Another benefit is the ease of use of these types of approaches for screening, at least. So it's still important to get the direct measurements of the viruses. That's going to continue to be very important. But as you remember, you needed special equipment for RT-qPCR. You had to have this more invasive, I don't know, would you rather have your finger pricked for a blood sample or have this nasopharyngeal swab done? And then you also would then have to do the RNA extraction, and then you also have to do all of the qPCR steps after you've done the RNA extraction, and then you do the reverse transcriptase aspect of the qPCR, and then you also then do the actual qPCR. You have to have the computer and the software to develop the CT values, the cycle threshold values, so that we can then estimate the viral titers in the presence or absence of virus. No virus there, high virus here, and some virus all through here. How do we do that on individual patients? You have to have a lot of the equipment. So we have a lot of benefits of using an approach like this for determining if somebody's ever been exposed, and it doesn't tell us whether they're sick or not. It just tells us whether they're exposed or not. But if they're exposed and they have increasing IgM levels, or even in this kind of range, they could potentially be infectious whether or not they actually have symptoms. And we also know that if we're looking for the virus 15, 16, 18, 21, a month, 2 months out, we're not going to find it. This article in the New England Journal of Medicine shows that, over a period of time since the onset of symptoms, there's a decline in the amount of virus that can be detected. Some people, you won't be able to detect it very quickly after even a few days, but most people, it tends to be able to be detectable for a while. But at some point, you cannot see the virus anymore. Your qPCR is never going to amplify any virus because there was never enough starting RNA to ever amplify anything. So with that said, we need these tests that tell us long-term who's been exposed, because presumably once you've had the antibodies, you can't get sick from this again. We don't know for sure, but that's the underlying presumption. And there have been tests that have helped validate that on animal models, and they've also been monitoring people. The cases with, quote, reinfection, many of them have been refuted, and we don't know about things being people being reinfected or not. So how do serological tests actually work? What makes these tests actually work? So, when a person has symptoms appear, and there may be an exposure period here as well, so they're exposed, they have no symptoms, the virus could be replicating in them and amplifying in them, so the virus levels will start to go up. But we don't measure virus levels with this test. We're measuring the immune response. So once the virus levels go up to a certain point, some people will have symptoms to start to appear. So here we're in stage 2 of disease. Here we're in that stage 3. They've got symptoms. Clinical disease maybe has onset. Or they never had clinical disease, but the seroconversion is starting. The immune response is happening. We're developing antibodies at this point. So usually when you start feeling sick, there's an immune response there as well. So that's when the antibodies start getting produced. And they'll continue to be produced. IgM, your short-lived, more rapid first responders. The IgMs are your first responders. And they're going to continue to be produced for, it appears to be 7 to 10 days or so for most patients that have a healthy immune system. People over 80 or weakened immune systems, this information may not be valuable or applicable. IgMs, these are the IgM antibodies. And they have these little specialized receptors that are created that will find things about the actual virus that they may like. Now, these aren't actual virus particles here. When they make these little kits, they make the antibodies to be able to detect certain like proteins or certain carbohydrates associated with the actual virus. So they simulate or mimic what would be on the outside of the virus. And in this case, they've simulated or mimicked what was actually on the outside of the virus, and they were able to do that much more easily and quicker because of the research that had already been done on the first SARS epidemic, or pandemic, I guess. So we have IgG and IgM. IgG is the immunoglobulin G. It is the most abundant type of antibody, and these are the more long-lived ones. IgMs are the first antibodies made to fight a new infection, and they are found in the blood and lymph fluid. So when you think of lymph, we're talking about our lymph nodes. You can feel them get swollen when people feel sick. The lymph tissue is where the battles are fought between the bad guys and our immune cells. So IgMs are the first responders, and they'll be abundant in the lymph fluid of the actual active infected patient. Now, when they make these antibodies, they may create these fake, they're still glycoproteins, but they're very similar to the actual viruses. So they obtain these things and they put them all throughout the body. Similarly, this kind of stuff goes on with vaccine manufacturing as well. But they end up creating these special receptors that our body will go after and say, we don't know what these things are, capture them. And we'll be ready for them the next time we see them. So that's a little bit about how this type of testing is done. So if a person is negative, okay, they're negative, what does it mean? If they're IgM positive, what does it mean? IgG positive, IgM, IgG positive. So there's a lot to learn here about what these results will mean. So I'm going to pause this video here because it's already been a little long, and I'm going to start back up here in a second at this point.